Hello everybody, this is Daniel. Here we are going to have yet another experiment with Notespace. This library is getting closer to version 3, which is still experimental. And here I'm mainly trying to show the state of things and provoke some discussion so that we can think together. What we will see is affected by important comments by several community members, and it is also very much inspired by other more serious projects such as Oz and Pingorilla mainly. What are we trying to do? I think we wish to have our work done somehow in the Lisp way. And what it means is maybe to have things very much visible and open to exploration with joy. And we wish to have our tasks of coding and data exploration, visualization, and documentation and testing, all that, we wish to have that in some harmony, maybe with the tools. And the tools are the editor and browser and the Clojure REPL and our mind. And let us see how these things can maybe connect. So let us do something. Here we have a Clojure namespace. And that namespace is requiring just the main entry point of the Notespace API. And the first thing to do would be to initialize the Notespace system. And to do that, we will use a key binding of the editor, Spacemax in this case. And this key binding will call a Clojure function that will initialize. So I have this key binding, and I'm going to initialize with a browser so that we can see things. Okay, so we see the Clojure function called, and we have a browser. Yeah. So now the 4 players of the party are here. You, your REPL, your beloved editor, and your browser, Firefox in this case. So they can play. We can write some code and maybe some data. And we now wish to evaluate our namespace, but we wish to do that in a way that informs the notebook about the results of evaluation. So we have yet another key binding that calls a Clojure function, and we evaluate and inform the notebook, and the notebook knows and you see both the code and the evaluation results. Another thing we may like to have is some text. So at the moment we have this notation, even though there are some other maybe better options like using comments that still needs to be discussed. And so we can have like some subsection about Markdown, and we have some text. So here we are creating some Markdown strings, and we see that they can render as Markdown. Behind the scenes, what is happening is that we have 2 different kinds of notes. The first 2 notes are of the naive kind. They just render by printing the result. Here we have a note of the Markdown kind, I mean. And that means that it renders as Markdown, as we see. And that is a decision of the notebook system, because these vector strings, that's a default, but sometimes you want to be explicit. So let us be explicit, for example. Let us create another sequence of Markdown strings, maybe a list of something. Yeah. So, oh, sorry. So here it is. That is how it renders by default, naively. But now we wish to specify another node kind. So let us add another namespace here, which is Notespace kinds. Let us call it K. So we can add some metadata now. K markdown. And that means that it renders as markdown. And we also have a similar kind called as markdown, which means that it renders the same, but now you will see the code too, right? Okay, another thing is hiccup. So let us create a hiccup node. Hiccup. And now we have a new subsection, this time defined as hiccup. Yeah, and another thing is having things as hiccup. And now let us mention another thing, and that is our rendering engine is actually based on a library called Gorilla UI. This library is part of the Ping Gorilla notebook system, but it is useful as it is standalone and can render not only hiccup, but an extended version of it with additional tags that actually are wrapping certain JavaScript libraries in a declarative way. So for example, we can have a tag of the sparklines type that can render some data. Let us have maybe a random walk. Let us have this randomness function that is unbiased, and let us call it repeatedly many times and have the partial sums of it. And so that is our data, and we can specify some other properties of the plots, like the height. That is useful. So, oh, what did I forget? Of course, I forgot the node kind. So we wish as a cup. Okay. Another thing worth knowing is that sometimes we wish to reevaluate one node, one specific node. And again, we have a key binding for that. And here the editor has some useful knowledge, which is the line where we are. Yes, we are at line 31. And it is going to tell Clojure, you need to reevaluate the node at line 31. So let us do it with another key binding. Yeah. And now we see that every time we do it, our random walk is updated from scratch. Right? Okay. So another thing to talk about is time. What would we do if we have some things which are costly in terms of time, which take time to compute? So one kind of situation is Clojure futures, things that run in the background. You wouldn't want to wait for them with your workflow, but you want them to be ready when they are. So for example, let's define something like X, etc. And let us have it slow. It sleeps for 3 seconds and then computes the number 3. Yeah. So you see, we have defined X, but how would we consume it in the notebook when it is ready? So for that, we have a certain macro of the main API namespace, and it is called F. And what F does is, F is very similar to a Clojure future, but it is a future that informs the notebook so that the notebook knows when it is ready. So let us maybe have something of this kind, like use X, reference it, and add some number. So now when we recompute, we see that after 3 seconds, that is ready. And the notebook knows because the F thing did inform it about it. Let us maybe have another one, more complicated. Y, did that, and wait some more, sleep 2, and then return Y. So now we have something that not only waits for X, but afterwards it waits a little more. Let us see. So X is ready after 3 seconds, and the other one, oh, it didn't wait too much. Let us have it a bit more. Yeah? So X is ready after 3 seconds, and the other one waits 2 more seconds, and then it is ready. Yeah. Now about another time-related semantic, and that is delay. Yeah, so delays in Clojure are things that wouldn't happen unless you ask them to. So if we now have something like Z delay +2, then evaluating this wouldn't cause this expression to be evaluated. Rather, only after we dereference Z, it would be evaluated. And we want to have some similar notion in the notebook experience. And how would we have that? So for that, we had another macro called D, which is called delay. And the way we use it is, the way we use it is like that. So D, maybe have some slow thing for fun. Yeah. So D wouldn't happen when we evaluate the notebook, the note space. Let us see. So all the slow things are happening except for this one. It is not going to happen for now. We need to ask it to. So now we come back to this key binding that talks with a certain single note. And this function actually not only evaluates, it also realizes it if it is something of the kind of a delay. So let us see. So I call the thing at now line 53, and now it is there. And yes, we can have it like more sophisticated, like maybe some hiccup. And it will work too, I hope. So I evaluate everything, and now we can ask it to happen. And we are going to have a big 3, I hope. Yeah. Okay, so these were some examples of the current behavior, and they are different from the previous notions of Notespace, and there are some good things about the previous way, and it might be a pity to lose that. On the other hand, I think this way is a bit more simple, and sometimes simplicity brings some new kinds of surprises, which are good. And I think we have seen that here. And we need to talk at the moment. We need to think and talk how we kind of find maybe something in the middle between the two versions. And anyway, I hope this does provoke some thought about how the browser and REPL and editor and you can interact. And now, please let us talk. Thank you.